In this section, we are going to talk about Euclid's division lemma, which is also known as Euclid division algorithm. What is it, right? So we'll first talk about HCF of two numbers. We'll see how do we go and calculate HCF for two numbers. Then we'll go and see how can we utilize Euclid's division lemma or algorithm to calculate HCF of two numbers. And then we'll look into some examples. So let's start with HCF of two positive numbers. Let's find HCF, which is also known as highest common factor of 8 and 12. Step 1. We'll try to find factors of 8. In order for you to find factors of 8, what you need to do is find all numbers which can divide 8 and do not leave any remainder. And if you try, you will see 1 can divide 8, 2 can divide 8, 4 can divide 8, and 8 itself can divide 8, leaving no remainder. So these are 4 factors for number 8. Now let's take a look of step 2, which is find factor for number 12. Now you can easily see the numbers which can divide 12 and do not leave any remainders are 1, 2, 3, 4, 6, and 12. Now since we have find factors for number 8 and number 12, we'll move to step number 3, where we'll look for highest or largest factor which can divide both number 8 and 12. Now since we know the factors for 8 is 1, 2, 4 and 8, and similarly factor for 12 is 1, 2, 3, 4, 6, 8. Now try to find highest factor between 8 and 12 which can divide both the number, and you will figure it out. It's nothing but these two 4, which is common between 8 and 12 and is the largest number which can divide both, and hence HCF for 8 and 12 is 4. This is our standard way to calculate HCF of any two positive number. So remember, HCF of two positive number A and B is the largest positive integer D that divides both A and B. So how do you calculate HCF of two positive number? You have to find largest positive integer, which in this example is D, which can divide both A and B at the same time, leaving no remainder. Now let's talk about what is Euclid's division lemma or algorithm. So Euclid's division lemma or algorithm is a technique to compute the highest common factor of two given positive integers. So this is a technique through which we can compute highest common factor, which is also known as HCF, of two given positive integers. Let's take a look. Let's take some example. Let's take same example which we have just seen in the previous slide, where we were supposed to find HCF for number 8 and 12. How can we use Euclid's division algorithm to find HCF of 8 and 12? We start with largest integer, and that is 12 in this case, right? And we'll start 12 as dividend, and the smaller integer 8 as divisor. Then we will use Euclid's lemma to get dividend equal to divisor, which is 8 in this case, multiplied by quotient, which is 1, plus remainder, which is 4. So now, in order to identify HCF, we'll take the biggest positive number for which and then you will take the lowest one, and you will use lowest one as divisor and the biggest one as dividend, and you will try to represent the biggest number as a combination of lowest number multiplied to some quotient and whatever is left as remainder. In this case, we have expressed 12 as 8 multiplied by 1, which gives you 8, and when you add additional 4 to this, what you get is 12. So in this case, 4 is my remainder. Now consider the divisor 8 and remainder 4. So now we'll start divisor 8 and remainder 4, and between these two numbers, divisor 8 is bigger, right? So I'm going to now use division lemma or algorithm again between 8 and 4. And now we can represent 8 as 4, which is as divisor, multiplied by 2 as quotient, and if you multiply 4 and 2, what you get is 8, so there is no remainder, hence in this case remainder is 0. Notice that the remainder has become 0 and we cannot proceed any further. Hence, we claim that HCF of 8 and 12 is divisor at this stage. Now at this stage, what is my divisor is 4, and hence 4 is HCF for number 8 and 12. Now let's talk about Euclid division lemma and algorithm and try to understand it in a better way, right? To obtain HCF of two positive integers, say C and D, with C is greater than D, follow these steps below. Step 1. Apply Euclid's division algorithm or lemma to C and D so that we can find whole number Q and R such that C can be represented as divisor D multiplied to quotient Q plus remainder R, and in this case R can be 0 or greater than 0, but it is always going to be less than D. Step 2. If you happen to find R as 0, then D, which is divisor in this case, becomes HCF of C and D. But if you do not find R equal to 0, then apply division lemma or algorithm to D and R. D and R. And continue. Step 3 will be continue this process till the time you get remainder as 0. And once you get remainder as 0, the divisor at this stage will be the required HCF. So that's what pretty much is Euclid division lemma or algorithm. So Euclid says in order to find HCF of any two positive integer C and D, where C is greater than D, you try to represent them in terms of divisor D multiplied to quotient Q, and if there is remainder left, then that remainder is R. If at some point of time you get remainder as 0, then whatever is your divisor at that point of time becomes HCF of C and D. Remember, Euclid's division lemma and algorithm are so closely interlinked that people often call former as division algorithm also. So people also call this is my division algorithm. And another thing to remember, although Euclid's division algorithm is stated only for positive integers, but it can be extended for all integers. That means it can be extended for negative integers as well, except 0. However, we are only going to focus on positive integers for this class and will not look into negative integers. Now let's take an example to find HCF of 4052 and 12576 using Euclid's algorithm. Step 1. We got to first identify which number is greater, and we can easily say 12576 is greater than 4052, and hence we will apply division lemma or algorithm to 12576 and 4052 to get 12576 represented as the smaller number as divisor multiplied to some quotient and whatever is left as remainder. In this case, 12567 can be represented as 4052 multiplied to 3, and whatever is left is 420. Now we go to step 2, because in this case my remainder is not 0, so I have to continue this process, and in this case I'm going to use 420 as divisor and 4052 as dividend, and hence we can represent 4052 as 420 multiplied to quotient 9, and what is left is 272 as remainder, and in this case also we do not have remainder as 0, so we got to continue further. Now we'll try to represent 420 as combination of 272 or any remainder left. So we can represent 420 as 272 multiplied to 1 plus the remainder as 148. Again, in this case my remainder is not 0, so I have to move further. And now we can represent 272 as 148 multiplied by 1 plus 124, and even in this case my remainder is not 0, so I have to move further. Now if you try to represent 148, you can with 124. 148 can be represented as 124 multiplied by 1 plus 24. I still have remainder and it is not 0, so I have to move further, and now I have to represent 124 as 24 multiplied by 5 plus 4, and even in this case my remainder is not 0, so I have to move further. And now I can finally represent 24 as 4 multiplied to 6 plus no remainder left, so plus 0, and at this point of time my remainder has become 0, so we can stop the process and say the divisor at this stage is 4, and hence HCF of 12576 and 4052 is 4. Thanks for watching. You can visit us on www.classisfun.com. Thank you.